Hi, this is Dan Blurred, retired electronics engineer, sitting on the front deck of my houseboat out here on Multisite Channel, and I want to talk about something, get off the subject of harmonics for a bit and talk a little bit about some of the more fun things I did. This one was in, I documented, or whatever you want to call it, in The Reluctant Road Warrior, and in this book I talk about the things that I did in my life, in my career, and one was kind of interesting. I was working for Next Test, which was, I was a marketing applications engineer, which was perfect for me. It was wonderful. So I didn't have to go and sit in somebody's test floor and write code and solder wires and design hardware. I didn't have to do any of that stuff. I just had to travel around and talk to people. And so my sales guy, or one of the sales guys in Next Test, Marty Mason, said, we're going to go to Boston and we're going to talk to Analog Devices. So we flew out to Boston and had a meeting with this guy at Analog Devices. I think his name was Malone. And apparently Marty knew him. He introduced me and we sat down and talked, you know, and so Marty was kind of talking to him about what we're doing, what our Next Test Lightning was, and he made the incredible claim. I should almost quote it out of the book. He said, we're new to mixed signal, we're not really sure we know what we're doing, so I'd like you to listen to Dan and see what you think. I'm like, thanks for the intro, Marty, you bastard. So I pulled out my laptop and I had a demo all set up for him, showed him the MSWT, the mixed signal wave tool, and I showed him how we did FFTs and how we looked at INL, DNL and stuff like that on the DAC. And after a couple minutes I wrapped it up, and this Malone guy says to Marty, I think you know what you're doing. So he agreed that we might be able to do something for him, and the target product was Analog Devices MEMS products. Now, if you don't know what a MEMS is microelectronic machinery something. It's a machine basically in done with silicon and etched and everything like a chip, an electronic chip, but there's mechanical elements in there. And this guy's product was a two-axis accelerometer. So they use them in all kinds of things. You know, friggin' when you're driving in your car and if you run into something, the accelerometer is what says, oh, it's time to fire the airbags. Poof! And your airbags go off in your face. All kinds of things. Drones, helicopters, all kinds of stuff. And your phone, when you turn your phone sideways and it notices that and flips the picture for you, that's a MEMS device. Now, the MEMS things they're really cool. Basically, the MEMS device that they wanted me to look at put out a DC level relative to where the X and Y was on that device, so where it was pointed. And it was really, really fun to play with. So this guy gave me a couple of MEMS devices and sent me off and said, okay, we'll see what you can do with this. This is our test time on our tester, and I'll tell you more about their tester in a minute. And then, you know, see if you can get under that. So I took these devices home and I spent 2 days working on it and wired it up. And you know, it's tricky when the tester that you have has fans. The fan noise, any vibration of the fans is going to couple through the tester to the chip. And so this couldn't be done on the circuit board that's attached to the front of the tester. That's called a load board. So you can't do that. The MEMS device has to be separate so that the vibration from the fans and other stuff doesn't couple through it. And you think about some of the liquid cooled testers out there, that's all the turbulence from all that, you can't do that. So I used really thin wires to couple the signals to the device and make the measurements. So I did it, and I wrote the code, and it was in C++. And what I did was I basically replicated what they did, almost exactly what they did. And what they did was really cool. They used a basically what I did with my periodic white noise thing for testing filters. They did the same thing, but what the goal was they're doing a targeted periodic white noise. And he mentioned this, and I'm like, oh yeah, I have an article in the magazine about that, So it was perfect for me. The periodic white noise was meant to be driven into the device, where they had an electrostatic method of reaching the beam, and that would vibrate the beam. So it would vibrate the beam with periodic white noise signal, and the beam that senses your position or your relative position, that beam would resonate at some frequency, and that's really what they wanted to know. What frequency is the beam resonating at, so we can validate that it has the right length and the right mass, and then they can calibrate it based on that. So I did this thing, and here's some pictures from it. It was really cool. The waveform was kind of rough because they didn't make it smooth. You know how you make it really smooth? One way to do it, which I didn't do in that case, but they were sampling at some frequency, and I try to keep all the parameters the same because I don't want them to accuse me of cheating by doing something different. But what you could do if you want to get better resolution is you take more samples, or you sample slower, not faster, slower. If you sample slower, you get higher resolution. It is a lower bin-to-bin frequency in your spectrum. So, but I did it their way, and so I came up with these spectra, and I said, well, looking at it, it needed to be smooth. It had some rough edges in it, and that was due to the periodic white noise. And I came up with these beautiful results. Now, the really cool thing was, I was testing it on the Nexus Lightning in 1/4 the time it took for them to test it. And we were talking about doing multi-site testing when that was a big thing back in the day. Now it's like everybody's doing multi-site because the handlers can handle multiple devices at the same time, and the tester can test multiple devices at the same time. So because I did it in 1/4 the time, I could test 4 parts for every 1 part that their tester tested. So their tester, what was their tester? Analog Devices used to do this thing where they would build their own mixed signal testers. So they're experts at analog, right? So they would build their own mixed signal testers, and they got in the habit of selling them because it made money for the company. So they sold them to other companies. And then later down the road, Analog Devices would end up buying that company out, and they'd go to inspect the site, and the site was filled with their testers. And they're like, our testers are being used to compete against us. So some VP or something decided that no more, the mixed signal, the tester division's not going to sell testers to external companies anymore. Well, that was all fine, but they got revenue from that, and so the tester company, the tester portion of the Analog Devices division that did all this stuff, they lost out on money because the only money they could get was money that Analog Devices was willing to pay them. And before that, they were competitive with Teradyne and Credence and LTX and all these other companies that build testers. So they were losing money on that thing, and so what they decided was they're not going to allow external testers to be brought into Analog Devices. Now, that really messed things up because my tester could do the job it could do it more accurately, and it could do it cheaper because I could do 4 devices for one of their tester. And they decided that, no, we can't allow these testers in. Well, this guy, the manager that I talked to, he was furious. And so he disappeared. We never talked to him for a while. And then after a while, I got a phone call. And it was him. He was telling me about, he says, I wanted you, Marty, I can't get a hold of Marty, but I wanted you and Marty to be the first to know that I gave my notice at Analog Devices today. I said, what? Why did you do that? And he says, I can't stomach their position. So what I'm going to do is I'm going to take a job at International Rectifier. And they're in LA, but that's okay. I can fly to LA once in a while, and we'll end up buying your tester. And I'm like, oh my God. We ruined a guy's career just over this one thing. It wasn't me, but it was Analog Devices, really, their policy. So he went to International Rectifier, and he met all the people in the test group, and we sent an apps engineer, Steve Holder, down there to talk to them about our tester. They weren't interested. Now, I don't know if it was because Steve's not as personable as me or not as knowledgeable as me. I don't know. But I hired Steve Holder because he was one of the few guys that would come to work for me over at Next Test. And so he abandoned Credence and went to work for Next Test because I dragged him over there. And then when we put him up there in front of a customer, he couldn't do it. He just couldn't pull it off. Now, that doesn't mean that I would have done any better, but, you know, it's worth a shot. Anyway, it was a really fun experience, and it was really sad that Analog Devices wouldn't accept our tester because he would put their guys out of business. Too bad. Like, you know, do what's right for the company. Don't do what's right for your stupid decisions. And, you know, Analog Devices is still in business. They just bought out Maxim some time ago. So it's not a terrible thing, but they lost good people. And this guy had to commute from Boston to LA for a while until he finally opened up an office for International Rectifier in Boston. On that, I want to add one more thing. When we were playing with these devices, one thing I did was this cool little trick I did. I took his device and I attached it to a hacksaw blade, chucked the hacksaw blade in a vise, and then strummed it. And when I strummed it, it oscillated back and forth, as you see here, and you can see it's blurry. And what it did is it made a sine wave. So it's, you know, MEMS is cool. Now that's not the only MEMS thing I did. We got so much into MEMS that for the next semicon, my last semicon at Next Test, because I was out of there, I knew it was going wrong. And so we went to semicon with this thing that me and Steve Holder built. It was really cool. It was a golf club, and in the golf club we hollowed out the bottom and then put in an XY accelerometer and a gyroscope, a MEMS gyroscope. Now these are just MEMS devices you can buy. Now with those two devices in there, what we could do is you could swing the golf club and the impact would be felt in G's by the accelerometer. So we could get the G's that we hit the ball with, which would allow us to predict how far the ball would go, because all golf balls weigh pretty much the same. So we could figure that out, and the gyroscope allowed us to figure out the head position. So was the golfer holding the club the right way for a good shot, or was he going to get a slice or a hook? And so we built this thing, and yes, it was wired because we didn't have wireless at the time, but we took it to semicon in San Francisco, And I tell you, man, people lined up for that fucking thing. We had people lined up in our booth to do golf, to play golf. It wasn't play golf. It was just to try our simulator. And what I had done is I had researched a whole bunch of golf stuff. Do you know what Lee Trevino said about golfing in a rainstorm? He says if you find yourself on a golf course in a rainstorm and the lightning starts striking, hold up your 1-iron, because even God can't hit a 1-iron. That's brilliant. So I got to research all this stuff on golf. I never play golf. I hate golf. And so, but I got to research it. I got paid good money to research golf and do all these funny messages that it would put out. And I swear to God, I was there for the show. And we had people coming up and they'd swing and the tester would tell them how fast their ball would go and whether it was a hook or slice. And I had people saying, God, I always slice it. I don't understand why I'm doing that. It's like, it wasn't, it was not a simulation. It was real. It was capturing what they really did with that golf club. Because what we do with the gyroscope is we had them calibrate it, hold it there, face to face with the ball, and then when they get through the swing, is it pointed the same way? That's what the gyroscope told us. Now we had to digitize the X and Y and the gyroscope. Well, the problem is the Nexus Lightning could only take 2 mixed signal boards, and that meant 2 analog capture instruments that we were capturing with the data, capturing the data with. And so we couldn't do X and Y and the gyroscope. We had to find a way to get the X and Y together. So what we did was I came up with a circuit, really cool. How do you turn one signal into 2? Well, the gyroscope is an X and Y, and so what I did is I decided, okay, let's take the X and Y and we'll square them. So I built an op-amp circuit. It would square the X, and then it would square, a different circuit would square the Y. And now the X and Y are squared with a, it was a multiplying DAC. And so then I would sum them. So basically you multiply a signal by itself, and then you multiply another signal, Y, by itself, and now we have 2 signals, and then you run it into another op-amp, and you add them together, you sum them. So the sum of the squares. Now we have a single signal we can send to the tester, and the first thing the tester does after scaling everything was to take the square root. Square root of the sum of the squares. Does that sound familiar? It should. So we turned the 2 signals into 1 by doing the square with an analog multiplier and op-amps that would add the 2 together and give you a single signal, which was the square root of the sum, or sorry, it was the sum of the squares, and then in software we would take the square root. Pretty hard to do square root in electronics. So square root of the sum of squares, so that was our accelerometer output, and that was, all that stuff was coupled through the handle of the golf club. And so the people who played this thing, they had to have a wire connected to them, but it was okay. They didn't mind. And I swear we had a line out the door, out the booth of our booth, out the door of our booth, and it was friggin' great. We had such a good time, and participants of the Semicon were there, and they loved it. And I had people come up to me and say, one of our guys in our booth says he got this score. Is that really true? Because I want to beat that. I think my golfing is better than his golfing because I beat him on the course. And so we'd say, go ahead and try it. So they were arguing with each other about how well they could hit the ball. It was freaking great. And so at the end of the show, we're wrapping up and trying to put everything away, and all kinds of stuff had to get put into boxes and shipped off because I got to help with that stuff. And my boss is looking over the booth that he did as a golf course. He did it he had it built as a golf course. He must have spent $1 million on it. Because we're in the Expo Center at the San Francisco Expo Center doing this show, right? And so he says, gee, I can't remember why I came up with the golf course theme. I'm like, Rick, you dumb shit. Because me and Steve came up with the golf club. That's the only reason this looks like a golf course. And you can actually find a link to that. I think it was a 2006 Semicon West Next Test. Look it up. You'll find it. We did it as a golf course. And he didn't remember why he did it as a golf course. Because we came up with this golf club. It was really cool. Anyway, that's enough of MEMS. It was fun stuff. I like MEMS. And I really appreciate MEMS in my camera, in my phone, in my car, and all kinds of things. There was MEMS everywhere. So you have to test everything. You have to test every fucking chip that goes into any electronic device. And so I've tested many, many things, and I've done MEMS, and I think MEMS are really cool. You got to be careful with vibration and stuff like that, but otherwise, how do they do that in wafer sort? Got me. Can't do that on wafer sort. I don't know, but they do it, and they're successful at it. Anyway, that's enough for now. This is Dan Bullard on the river. See you later.